Time travel. That's something that we physicists actually look into. And we realize that if you have a wormhole, there is a theory that you can go backwards in time. Now, in 1935, it was Einstein himself who postulated the existence of wormholes. If I have two universes parallel to each other and I create a bridge between these two universes, then you fall into one and go into the other. Now, the energy to do this is the energy of a black hole. So in other words, if there's a white hole on the other end of a black hole, it means that you can fall in and fall out someplace else in the universe. And in quantum mechanics, there's something called the many worlds theory, that every time a measurement is made, the universe splits in half and keeps on splitting every time there's an observation being made. And so maybe when you go backwards in time, the river of time forks into two rivers. If you go backwards in time to save Abraham Lincoln from being assassinated at the Ford Theater, you've saved somebody else's Abraham Lincoln. Your Abraham Lincoln in your river of time died with an assassin's bullet. That cannot be changed. But the river of time splits and forks, and you've saved another universe's Abraham Lincoln from being assassinated. That is what we physicists think is a possible resolution of all time travel paradoxes. The river of time forks. All of biology can be explained in the language of chemistry. All of chemistry can be explained in the language of physics. But all of physics can be explained in the language of relativity, like the Big Bang, and the quantum theory, which gives us transistors and lasers and the internet. The goal is to merge these two great theories to create an equation, 1 inch long maybe, that would allow us to unravel the universe itself. That's the holy grail of science. We are all born scientists. When we're born, we want to know why the sun shines. We want to know where we come from. But then we hit the greatest destroyer of scientists known to science. The greatest destroyer of scientists is junior high school. Because in junior high school, that's when scientists made boring memorization, lists of names and facts and figures you're never going to use anyway, that are totally irrelevant. Because, science is based on principles, concepts, physical pictures. That's what drives science, like evolution, like relativity, like Newton's laws. And so that's why we lose so many people in the danger years, 15, 16, 17.
Wow,
those are the danger years when we lose millions of young kids. I like to quote Galileo, who once said that the purpose of science is to determine how the heavens go. But the purpose of religion is to determine how to go to heaven, how the heavens go, how the planets move, how the galaxy moves, how to be a good person, how to obey the laws and help your neighbors. But as long as we keep these two things relatively separate, they are complementary. So I don't see any contradiction between the two.
What do you think happens when we die?
I begin to realize that science is closing in on mortality. Genetic immortality is a possibility, and also digital immortality is a possibility. For example, everything known about us can be digitized. Our credit card transactions, our emails, to give an approximation of, who we are, our digital soul. Why do we die? We die because of the buildup of error. Error in our DNA, errors in our cells, because of chaos, the second law of thermodynamics. Things rust, things fall apart, things die. But if you add energy from the outside, you can get around the second law of thermodynamics. For example, with gene therapy, we'll be able to attack aging at 3 levels. One is telomerase. You see, telomerase also is used by cancer cells. Cancer cells are also immortal. That's why they kill you, because they are immortal. And that's one way that cancer cells become immortal. So we have to control telomerase. Second, we know that if you want to live 30% longer, eat 30% less. Why is that? Well, we're not sure because you slow down the oxidation process. Why do cars get old? What ages in a car? Well, it's the engine. Why the engine? Because that's where you have combustion, oxidation, wear and tear. Well, where is the engine of a cell? The mitochondria. Bingo. We now know where errors build up in a cell, the mitochondria. And with gene therapy, with CRISPR technology, one day, I think that maybe our grandkids will hit the age of 30 and stop. They may like being 30 for many decades to come. I think that's well within the realm of possibility,
Wow.
given the rapidity with which we are now unraveling the question, why do we have to die? Well, there is a benefit to dying, and that is on a societal level, you don't want to stagnate. You don't want ideas that are old, crusted, and obsolete to dominate young people who may think differently. So on one hand, you want to transport the wisdom. You want to get the wisdom of a generation and give the next generation that wisdom of life. That's why I say that in the future, when people live forever or live very long, when they hit the age of 30, that's a good age to stop because you're still young enough to have vibrant ideas, but you still have the wisdom of the first 30 years of your life. Look at it this way. Why do we have to die? Look at the Greenland shark. The Greenland shark lives to be about 500 years of age. We know that because just like tree rings, you can look at the eyeball of the fish, count the rings, and calculate the age of these fish, and they are between 400 to 500 years of age. So in other words, why do we have to die? In the Arctic, where these fish are, metabolism is much slower. And slower metabolism means errors build up slower. And again, that's what aging is, the buildup of genetic and cellular mistakes. They build up, cells get sluggish, they eventually die as a consequence. But in worms, for example, we can actually double their lifespan. And as I mentioned, you can take any animal up to humans and make them live 30% longer. Now, this has not been tested in humans, by the way. It's been tested in dogs, cats, primates. You eat 30% less, you live 30% longer. Well, aging backwards would violate the second law of thermodynamics. The second law of thermodynamics says that in a closed system, things decay, things get older, things fall apart, things die. The key word is closed. In a closed system, things naturally get older. In an open system, like you have sunlight, energy from the sun, that can reverse the process. That's how evolution takes place. Evolution should violate the second law of thermodynamics. People get, if you take a look at human evolution, we got smarter, we got more adapted to the environment. Why? Because we had extra energy from the outside, sunlight. Now that open system could be biochemistry. And so biochemistry could replace sunlight and speed up this process. Instead of waiting millions of years for evolution to catch up, we may be able to do it in one generation.
Have you ever been curious about testing your own brain?
I've had my brain scanned several times. I've hosted a few documentaries for BBC television, and they flew me down to North Carolina, where they have one of the finest MRI machines. And you can actually see thoughts as they emerge in the brain. You can actually see centers of the brain light up like a Christmas tree. And so many of the secrets of the brain are being revealed. For example, the back of the brain is the so-called reptilian brain. It's the brain of hunger, balance, aggression, the brain that a snake would have in the back of the brain, or an alligator. The center of the brain is more or less the monkey brain, the limbic brain, the brain of social structures. That is the brain of how to defer to your elders, how to be kind to people. The brain that involves pack mentality. That's the center of the brain. And then the question is, what are we? What separates us from the animals? What separates us from the animals is the front of the brain, the prefrontal cortex. And so what does it do? What separates us from the animals? The front of the brain is a time machine. It daydreams. It constantly conjures up images of imagined futures. For example, let's do an experiment. Go home tonight and talk to your dog and teach your dog the meaning of tomorrow. Very simple. Teach your dog the meaning of tomorrow. You can't. It's impossible because animals live in the present. Their prefrontal cortex is not fully developed. They don't imagine the future. And that's what separates humans from animals. We live in the future. Brain scans constantly show that when somebody is daydreaming about the future, they're actually accessing the past memories, and then altering it to create alternate futures. That's how we recall images. If you brain scan an animal, you find out that they don't think about the past, they don't think about the future, they only think about the present. So that's what separates humans from animals. Humans live in the future. We constantly daydream, plot, scheme. We're constantly thinking, what can I do? What does that mean? Why is he saying this? We're constantly thinking about gossip, about alternate futures. What if I did? What if I did this? What if I did that? That's called humanity. That's why we differ from the animals, because if you read the mind of an animal, all they're worried about is where's lunch? Where's dinner? That's pretty much it when you brain scan an animal.
We hope you found this video valuable. Let us know what your opinion on all this is down in the comments section. And don't forget to like it, share it with your friends, and subscribe to our channel for more content just like this.